Have you ever stared at a big list of numbers and just your eyes glaze over? It feels like total chaos, right? A meaningless jumble. But what if I told you there's a way to turn all that noise into a crystal clear story? Well, there is. Let's dive in. Okay, just look at this. These are the test scores for 70 different students. Now, what does this wall of numbers actually tell you? Anything? Are these good scores? Are they bad? I mean, who did well, who didn't? Just by looking at it like this, it's pretty much impossible to say. This is what we call raw data, and honestly, in this form, it's not very useful at all. And that is where statistics comes to the rescue. It's literally the science of turning that messy jumble of numbers into something that makes sense. You can see it's a whole process, right? You got to collect the data, then organize it, present it, analyze it, and finally, the most important part, interpret what it all means.
So where do we even start with that wall of numbers? Well, the very first step before we do any kind of fancy calculations is just to bring some order to the chaos. We have to get organized. And the absolute best tool for that job is something called a frequency table.
Building one of these tables is actually a pretty straightforward three-step process. It's all about creating organized buckets for our data to fall into. So, step 1, we find the range. That's just the highest score minus the lowest score. Easy enough. Step 2, we decide how many buckets or classes we want. Now, that formula looks a little scary, I know, but it's really just a handy guide to help us pick a reasonable number of groups. And finally, step 3, we figure out how wide each bucket needs to be. We just take the range and divide it by the number of classes we picked. That's it.
And here's what we get. This is our frequency distribution table. And just like that, the chaos is gone. We can see at a single glance that the biggest group of students, 11 of them, scored somewhere between a 59 and a 66. A clear pattern just jumped right out at us, a pattern that was completely invisible before. Now that's the power of just a little bit of organization. Okay, so our data is organized. That's a huge step. But now for the next big question, is there a single number that can kind of represent the entire group? This is what we call finding the central tendency, which is just a fancy way of saying we're looking for the center of our data. And for that job, we've got three main tools: the mean, the median, and the mode.
First up is the one you definitely already know, the one we all learned back in school, the mean. You probably just call it the average, and it's the most common way to find the center for a really good reason. It's super straightforward to calculate.
Let's make this real. Say we have 6 students with these test scores. You just add them all up, divide by the number of students, in this case 6, and boom, their mean score is 82.5. The key takeaway here is that we've just boiled down 6 different numbers into one single representative value.
But the mean has a dark side, a big one. It's really sensitive to extreme numbers, what we call outliers. Just imagine this. You've got a room of 10 people, and they all make about $50,000 a year. Then a billionaire walks in. All of a sudden, the average income in that room skyrockets to millions of dollars. Is that really a typical value for the group anymore? Not at all. And that's exactly why we need other tools in our toolkit.
Which brings us to our next tool, the median. The median is quite literally the middle value. The only trick is you have to line up all your data points in order first, from smallest to largest. Take a look at these blood pressure readings. Once we get them all lined up in order, the number that's sitting smack dab in the middle is 121. And that's it. That's our median. By the way, if you have an even number of data points, you just take the average of the two numbers in the middle.
Now here is the median's superpower. It couldn't care less about outliers. If that last blood pressure reading was a crazy high 1,000 instead of 135, guess what? The median would still be 121. It gives us a much more stable, robust idea of the center when we have those extreme values. The only downside? It kind of ignores what's happening with all the other numbers in the set.
All right. Our third and final measure for finding the center is the mode. This one is probably the easiest to get your head around. It's simply the number that shows up the most often. You can think of it as the most popular or most fashionable value in your data.
In this list of typing speeds, if you scan through, you'll see that the numbers 115 and 121 both pop up twice, which is more than any other number. That means this data set actually has 2 modes, and we just have a simple name for that: bimodal. It's totally possible for a data set to have one mode, more than one, or even no mode at all.
So the mode has this really cool, unique advantage. It's the only one of these measures we've talked about that you can use for non-numerical data. I mean, you can't calculate the average eye color, right? But you can absolutely find the most common eye color. That's the mode. The main catch, though, is that sometimes there isn't a mode or there are so many that it doesn't really tell you anything useful about the center.
Okay, pop quiz. We know how to find the mean from a nice, simple list of numbers. But what happens when we don't have that list? What if all we have is that frequency table we worked so hard to make earlier? How in the world do you find the mean when your data is already sorted into buckets?
Right, here's the formula. And I know, it looks intense, but stick with me because the logic behind it is actually pretty simple. That X with a little bar over it, just a symbol for the mean. The F is frequency, how many items are in each bucket, and the X is the midpoint of that bucket. So really, all this thing is telling us to do is, for each bucket, multiply its midpoint by how many things are in it, add all those results together, and then divide by the total number of items. It's basically just a weighted average. Let's see it in action. For that first class, 1 to 5 years, we find the middle of it, which is 3. We then make a reasonable guess and just assume that all 5 of the employees in that group have a service length of 3 years. We multiply that midpoint, 3, by the frequency, 5, to get 15. We just do that for every single row, add up that final column, and then we divide that grand total by the total number of employees, which is 50.
And when we run the numbers for our 50 employees, we get an answer. A mean length of service of 16.2 years. Now, is it perfect? No, it's an estimate because we had to use those midpoints. But it's an incredibly powerful and fast way to find the average from data that's already been organized.
So we've spent all this time learning how to find the center of a bunch of data. The mean, the median, the mode. But so what? Why does any of this actually matter once you leave a statistics class and go out into the real world?
Well, the answer is this stuff is everywhere. It's used every single day to make huge, critical decisions. Businesses are constantly looking at average sales and costs. Doctors and scientists rely on these measures to see if a new drug actually works. Teachers use them to figure out if their students are grasping a new concept. This isn't just homework. It's fundamental to how we make sense of our world.
This quote just nails it, doesn't it? Our brains aren't built to look at 1,000 numbers and instantly understand what's going on. It's just too much. Statistics gives us the tools we need to boil down all of that complexity into just a few meaningful numbers. It helps us see the story in the data. So we've figured out how to find the typical value, that central point in our data. But I want to leave you with a question. If I told you that 2 different cities have the exact same average daily temperature, would you assume their weather is the same? Probably not, right? One city could be mild all year round, while the other has scorching summers and freezing winters. So the average tells us where the center is, but it's not the whole story. What important details might it be hiding? And what other tools do we need to uncover them? That's a story for another time.